Hi, my name is Amber Schroeder. I am a GIS tech at TCarta, and I made this video to demonstrate some of what TCarta has the capability of producing, as well as the different ways our data can be viewed in ESRI's ArcGIS Pro. TCarta's Global Marine Base Map is one of many WMS layers that are available for streaming bathymetry data. The Global Marine Base Map is created from TCarta's interpolated 90-meter bathymetry dataset, a specialized fusion of thousands of publicly available and private datasets including variable scale digitized nautical charts, multi- and single-beam echo sounder data, space-based and aerial LiDAR altimetry, 3D seismic multi-sensor satellite-derived bathymetry, and other sources. Viewers can get in touch with us to request access to TCarta's Global Marine Base Map for use in mapping softwares. Or you can also see the base map in our portal to explore sample datasets and submit any AOI polygons at explore.tcarta.com. In addition to the base map, TCarta also offers higher resolution bathymetry data, including satellite-derived bathymetry, both 2-meter and 10-meter resolution, and 10-meter or 30-meter interpolated grids. In this example of displaying a bathymetric surface in 3D, I used a subset of a larger raster produced from satellite-derived bathymetry in Bimini, Bahamas. When viewing data in a 3D scene, you can analyze the surface from all angles. To do this with a raster, the geotiff must first be converted to a tin, and then once the scene is created, you can layer the tin with rasters to view any dimension. The Raster to Tin tool converts a raster to a triangulated irregular network dataset that represents surface morphology. For smaller areas with projected coordinate systems, it is best to convert to a local scene for 3D viewing, but for unprojected, globally represented data like TCarta's Global Marine Base Map, it is best to open a global scene. A new tab will open where the data can now be viewed in 3D from multiple angles. To adjust any settings in the scene, click Ground in the Contents pane and then navigate to Appearance on the toolbar. I found that adjusting the vertical exaggeration to a value greater than 1 yields the best results for greater viewing analysis. From here, you can layer any rasters and/or satellite imagery on top of the tin to view any dimension. The image displayed is from Maxar's WorldView 2 sensor and the corresponding depth geotiff created from satellite-derived bathymetry that created the tin in the first part of this sequence. Another useful tool in ESRI's ArcGIS Pro for viewing bathymetry data is the Smooth Bathymetric Tin Maritime tool that does exactly what you'd think, but it also emphasizes a shallow water bias so that this smoothing is never a deeper value than the input. The smoothing algorithm can be customized depending on the amount of blending preferred between depth transitions, which would be location-specific or an aesthetic preference set by the user. The two tins displayed here is a difference between 3 passes and 10 passes. These next two tools are both used as alternative displays to visualize depth geotiffs. The Contour 3D Analyst tool generates contours from a raster based on input preferences set by the user that creates isolines between a specified interval of depth differences between cells. The contours can then be labeled, and the bathymetric surface can be easily analyzed for dangerous depth differences and features that were once difficult to identify. Similar to the contour tool, the slope tool is another 3D analyst technique that calculates the steepness of each cell in a raster. The slope tool, however, outputs another raster where the darker brown indicates steeper underwater terrain, and the lighter the shade, the flatter the terrain. In this example, the dredged channel has a very steep cut but a very flat surface, as to be expected. And the darker features in deeper water, with greater slopes, look to be patches of vegetation or coral reefs, where slopes would be much more apparent. Seafloor classification is another one of TCarta's specialties where a satellite image undergoes multiple transitions until the remote sensing analyst receives appropriate outputs against the imagery and any ground truth data available. When viewing seafloor classification data in ArcGIS Pro, symbolizing the polygons based off of the habitat subtype allows the viewer to compare the multi-part polygons against adjacent polygons. Adjusting the opacity of the polygons also allows for better analysis and a more accurate visualization of each classification. I hope you have enjoyed this rundown of TCarta's data in use. If you have any questions or would like to inquire for data, please visit tcarta.com.